now we're going to look at an idea called subsets. We're basically going to be looking at sets that are composed entirely of elements that are within other sets. Okay, just a quick definition and a couple kind of basic examples. Definition of set A is a subset of B, so you get two sets that are subsets, or one's a subset of the other, I should say. The bigger one is B, the kind of dominant set, and then A is a subset of that. So A is a subset of B if every element in A, everything in A, is then also in B, all right? And it's denoted with a symbol here. It almost looks like a less than or equal to symbol, except it's rounded off, okay? So, you know, in algebra or something, you might see, you know, the number 2 is less than or equal to 5 or something like that. This is a similar type of symbol, except it's round, right? So A is a subset of B, okay? A is typically smaller. We'll talk about some exceptions there. And B is typically bigger, okay, in terms of the number of elements. There are some weird exceptions to that, sort of. Okay, so every element in A has to also be in B. Every element of the subset is in the original set. Equivalently, we could say that there's no element in the subset A that's not in B, all right? So if you had an element in A that wasn't in B, then A could not be a subset of B. Then it wouldn't have elements exclusively found in B, okay? So let's look at a quick example. I've got sets D, E, and F. That way I could avoid using the A and B notation up there and get confused. D, I use D for digits. These are all of the 10 digits in our standard counting system. E is for the even digits, and F is for all the first 4 numbers here that are multiples of 4, okay? And so D for digits, E for even, F for 4, D, E, F. That actually kind of made sense as I wrote that up. Now, as I look at these, D seems to have the most elements, right? The cardinal number for D is 10, right? There are 10 digits here. The cardinal number for E is 1, 2, 3, 4, 5, and the cardinal number for F is 4. Now, that doesn't really help us out. I'm just throwing out some facts and getting an understanding of these sets. What I do notice is that every element of E, 0, 2, 4, 6, 8, occurs in the set D, right? 0, 2, 4, 6, and 8 are in here, sort of among the ellipsis. And so we could say that E is a subset of D because every element of E is also in D, okay? So every element in E is also in D, okay? Every element in E is also in D, and notationally, we would say that E is a subset of D, all right, using this notation with the subset symbol, all right? Now let's take a look at F for a moment. Let's compare F to D. F has the digits 0, 4, 8, which are also found in D. However, it has the number 12, which is not a digit, right? It's a multiple of 4, but it's not a digit. So 12 is not an element of D. Therefore, F cannot be a subset of D because it contains an element that is not in D, all right? So I would say there exists one element, and it doesn't matter how many there are, as long as there's at least one. And if there were more than that, it would still violate the definition. There exists one element in F that is not in D. Okay. Therefore, F is not a subset of D. Now to write not a subset, we use the subset notation with a slash through it. Okay. Kind of like a not equal sign, or a not less than or equal to. Okay. It's not a subset. You can also see that F compared to E, well, they both share 0, 4, and 8, but F does not contain 2 or 6, and E does not contain 12, so neither one is a subset of the other. Okay, so also we would say that E is not a subset of F, and F is not a subset of E. Okay. Okay, now maybe I could come up with another set that is a subset of D. Maybe I go with all of the digits that are multiples of 3. D, E, F, G. Let's go with G on that one. So let's say G is the set 0, 3, 6, 9. Well, now in this case, G is a subset of D because 0, 3, 6, 9 are all digits in here. 0 and then 3, 6 are in the ellipsis, and then 9. Okay? So we could say that G is a subset of D. Okay? Now G is not a subset of E or F because it contains 3 and 9, which are not elements of either E or F. Okay? All right, so that gives you an idea, just a very basic definition of subsets. Now, there's a couple interesting subsets. Any set ends up being a subset of itself. Okay, so we could say here that D is a subset of D because every element in D is also in D. Okay, and there is no element in D that is not in D. Okay, so every set is a subset of itself. E is a subset of E. F is a subset of F. G is a subset of G. Okay, every set is a subset of itself, and this works not just in this example, but in general. Every set is a subset of itself. Okay, every set is a subset of itself. That's very important, and we'll see that show up again later on. In addition to that, let's take a look at the empty set. The empty set is one of those weird sets, right? It doesn't have any elements in it, so what do we do with it? So we've got to consider the empty set. Now the empty set, let's compare it to D for a moment, okay? Let's see if it satisfies the definition. So we'd say the empty set is a subset of D if every element in the empty set is also an element in D. Well, let's pick out the elements in the empty set and see if they're also in D. Well, the elements of the empty set there aren't any. I can't even answer the question because there's no elements in here to test, right? So let's look at maybe the equivalent statement. Let's just see if maybe there's a better way to determine this. Equivalently, there is no element of A, or of the empty set in this case, there's no element of the empty set that is not in D. Okay, D is what we're looking for, right? Is there an element in here, in the empty set, that is not in D? Well, the answer is no, there's no element in there at all. So there certainly isn't an element that's not in D. Right, I don't have the number 7 in here, or 7, I have 17. Let's say, if 17 was in here, then I could say that the empty set is not a subset of D. But because there's no element in here, there can therefore not be an element that is not in D. Okay? So, by this equivalent statement, we can conclude that the empty set is a subset of D. And in fact, by some equivalent reasoning, the empty set is a subset of every set in existence, including itself. Okay? So we can conclude that the empty set is a subset of A for all sets A. The empty set is a subset of every set. Okay? Another way to write that then is the empty set is a subset of every set. Okay? So two interesting sets there. Every set is a subset of itself, and the empty set is a subset of every set. Okay? So a couple very interesting examples and a couple weird kind of exceptions. Not exceptions, just I don't know, interesting things to think about. Now there is another definition I want to talk about, and that is a proper subset. Honestly, it's kind of weird to always consider the set itself because these are equal sets, right? So D is not only a subset of D, but it's equal to D, right? So D is equal to D. And so it seems a little bit weird to have to write it this way. It's kind of like saying that, the number 2 is less than or equal to 2. Well, why don't we just say 2 is equal to 2 and forego the less than part of that, right? Both of these statements are true, but the bottom one seems to be a little bit stronger. And so what we're going to do then is we're going to define the proper subsets. Proper subsets are ones that are just, they're not equal to each other. Okay, so it's every set, any set that is not equal to it, or I'm sorry, any subset that is not equal to the other set. All right, so let's take a look at that. So we'll throw another definition up here. A proper subset of set A is any subset other than A, okay? Not the one it's equal to. All right, so we could say sort of equivalently, if A is a subset, of B, and A is not equal to B, then A is a proper subset of B. And the notation we use for a proper subset is going to look a lot like a less than symbol that's curved, kind of in a similar analogous way here. We would say that A is a subset of B. It almost looks like the letter C, but it's not quite the letter C. It's more of a horizontal U. When I write it quickly, it looks like a C, but it technically is not. So this is for a proper subset, and then just a general subset has the little equal line underneath it. Okay. Okay. And so hopefully that will, hopefully that clarifies a couple definitions for you.